Here's the problem. What makes that different to everything else we've done so far? And what sort of question is that? Do I ask silly questions sometimes that makes no sense to people's brains? Yeah. I look at your eyeballs and go, that made no sense. The double dot. It's not a first order differential equation. It is a second order. And before I go there, I wanted to talk about the other day on the pendulum. What did we start with? We started with trig as an x. Where did we get it from? The pendulum. And it become pretty obvious we kind of have a sine or a cos, so we started with trig. We differentiated it and got the v, or we actually got the graph of it, didn't we? Just from the pendulum. And then we ended up with the acceleration, and then we end up showing that x double dot is minus k squared x. So I like that for practical purpose of getting your brain connected, and then we go through the proof later. Here we go. I'm thinking about over and over. You guys can help me and come up with suggestions of how to make this clearer. This along. I can write that as d2x dt squared. And I think, would I write that? Is it best to write that? Why do I write that?
Understanding that we need to integrate to get back to x.
Got it. But we're not going to integrate once. Yeah, and we're going to do what to integrate? Separate the variables. So at the moment it looks pretty good because we've got an x and a t, so we've only got two variables. But the second derivative, of course, is a problem. So here's our first problem there. So we need to turn that into, I'm just going to make a statement, the v, the t. What is acceleration? Remember that's just, all it is saying that's acceleration. Oops, can't spell it. Acceleration, put it that way. Acceleration is the rate of change of the velocity. Do you see that physics? You tried, did they? Insert in your face. So we've now got that. Another problem though. Now here's what I wonder about historically, how long it took people to figure this out. And someone finally does it, and someone else doesn't, and they tell each other. I've got v, t and x, and now we're back to three variables. I don't want to over-explain it, but I think I've got it, guys. So what do I need? I've got it to v, I've got it to t, I need the x. And where can I get the x from? So what do?
Times by 1.
Times by 1. I've got your brainwashed. We times by 1, so I can just go dx, and put extras in. So what do I got now? I'm going to circle it that way. What's that called?
Velocity.
Yes. So we got velocity, the v, the x, equals minus k squared x. Now can we separate the variables? How many variables have we got?
2.
2 variables. So if I put all the v's on the left and all the x's on the right, too easy. I don't want to keep going too detailed. And that's a dx. So should I write that we separate the variables? Yeah, I'm going to write it. Video becomes too long now. What do I do next? Integral. So we take it from the second derivative back to the first derivative. So the first time we separate the variables. Now, what, Ash, tell me what to write.
V squared on 2 equals negative k squared x squared on 2.
Good. Plus
C.
Plus C. I think there's going to be a few people out there that would go, well, the integral of x is x squared on 2, and the k is just a constant. Now, problem. Now I've come up with this little diagram idea. The other day we were doing the pendulum. I started thinking about, and I mentioned to you the other day too, about if I had kids on the swing. So if I had kids on the swing. Okay, x here is 0. What's x there?
1.
We could say a maximum. We could make it whatever we want, 40, 60, like I did on the pendulum. But in general we refer to it as A. And we know that that stands for amplitude. So of course that would be x equals minus A. I kept on thinking about if I had my grandkids on the swing and I'm pushing them, what's their velocity there? What's their velocity there? The max. Just remember it could be a plus and a minus max, and that one is back to velocity 0. Which one of those three are we going to use to get the constant and y? Want to have a go then? Put into words. Which one?
Use A.
Yep. So don't worry about the negative case. X equals A and V equals naught. So I've got naught equals minus k squared a squared on 2 plus c. So do I need another step to say that that's that? No, I'm just going to go straight from there to there. And I've got v squared on 2 minus k squared x squared on 2 plus that on the other side, k squared a squared on 2. First thing we do in equations, get rid of fractions. V squared equals, will I write that first or that first? What does the world like to write first?
the positive.
Yeah. Tell me so I don't make a mistake.
K squared a squared.
Yep. I wrote it as if it's a fraction, doesn't
Yeah.
matter. Plus,
Take k
K.
squared x squared.
yeah, take our common factor.
So it's k squared bracket a squared take x squared.
And I'm going to go a little aside for a moment.
Mhm.
So when we get to there, the velocity is a max. So when x is naught, velocity is a max. So if I talked about when x equals 0, when x equals 0, v is a max. What do we end up with? I think I mentioned this the other day. Here. So that's 0. So we just end up with v squared equals k squared a squared. Yeah?
Mhm.
So I could go v equals plus or minus. Now you see where that comes from. Whereas the other day I think I just said a rule. And then people like to say the absolute value of Ka. Anyway, so enough said, that's a little side. So go back to here. So there's one of our formulas we're going to use. There's another formula we're going to use. Now make that back to v, the square root of k squared a squared. What have they ignored now? What have I mathematically done wrong there? When you get rid of square, you're right.
Plus or minus.
Plus or minus. So we're only doing the positive case. What do we want to do now? Separate the variables again and anti-differentiate again. So what am I going to write instead of that? dx dt. Alright, what have I got? What can I do with that?
Take out the k.
Yep. I go dx dt is k square root.
outside the root of a squared take x squared.
So now we're going to separate the variables. I've bothered writing it down. Makes it slow for you guys watching that. So what have I got? The x on the square root of a squared minus x squared equals k dt. Done? We're right?
Mhm.
Now we're going to get the integral of it again. So we've undone the second derivative to the first. Now first derivative back to what? So we get a solution to the question. What do we do now?
Substitution.
We need a substitution. Do you know which one? By not thinking, or have you seen it already?
I've seen it already.
Already. So if it was historical, I keep on wondering about the historical, and they're going, wait a minute, if I had another a squared there, I could take out the common factor and get rid of it. And they say, I know it's related to sine and cos, so therefore if I did a sine there, or you could do a cos there, wouldn't make any difference. Put a sine there. So what's the obvious one? Now, I can always write it the right way. X equals, we need an A and we need sine. And what letter comes to the rescue? What are we differentiating with? U. The x du equals A cos u. So the x can be replaced by A cos u du. So we're back to here.
Mhm.
So now I can write the integral of A cos u, and you go, woohoo, that's nice. U, I like to write it there. Some people like to write it up top. I got the integral of k dt. So if I was old school, I'd say substitute x equals a sine u. Yeah?
Yeah.
And then I'd go, well, that's a squared sine u, and we're nearly there.
Would be sine squared?
Yeah, do we shortcut it? Someone going to say, what did you do there? Common factor of a squared becomes a square root of squared. Is that what you just said then?
Yeah.
Good boy. Got the u. And what have I got?
Cut out the a's.
So I've got cos u on cos u. Is it cos u? Should I write the square root of cos squared u? Oh my goodness, it's writing too many steps in it. So I got cos u. Do I need to simplify it? Cos u on cos u is 1 to u. and they do write the 1, k to 2. And we got the weirdest, simplest.
U equals K2.
So U equals KT plus, and they decide instead of C, they decide to put,
Alpha.
this is, we know it's going to be phase shift. But we could have left it C and later on said, we like alpha, so say phase shift. So what are we going to do now? Substitute that back into there. Yeah, okay. Why back into there, not somewhere else? We want a relationship between X and T, and we want to eliminate U. So I've got X equals A sine. You okay?
Yep.
What do I write? KT plus alpha. Are we there? So all we had to do was go, that was U, I can replace that U up here.
Okay. Yes.
And of course, if you differentiate it, you got Ka cos KT plus alpha, and A equals, if you went instead of X dot, instead of X double dot. Last bit, and you've got cos becomes minus sine, so it's minus K squared. Oh my goodness, A sine KT plus alpha. And then I've got, what have I got? That's the same as that, so I'm back to where I started from, which is there. So if I went back to this one here, what's the acceleration?
Acceleration at that point is 0.
What's the acceleration there?
At the max.
0.
0.
So coming down the swing,
Oh, right.
you get there, you stopped accelerating, you start to decelerate.
Yeah.
So actually, so as pulling a spring, here's the best example then, go spring as well. Pulling a spring, time you pull it out there, the force is pushing you back, maximum acceleration. Should have brought in my ball worker, I got my springs. It whacks it back, yeah?
So with the acceleration at the ends, then what's... Oh,
So that's
max.
A is max,
Max acceleration.
but when we say max, negative. Whereas over here, A is max, and it's positive. So accelerating that way. You right?
Yeah.
So from there to there, we're accelerating negative, then it flips around. Decelerating positive. And lots of people want to talk about decelerating. Decelerating in that direction, which is accelerating in that direction.